Now, how we're ultimately forwarding the traffic on a per destination basis is going to be dependent on the load balancing method that we choose. In the case of the Nexus 7K, the load balancing method is defined in the admin VDC or the system VDC because that's something that affects the entire chassis. On the 5K doesn't, it only has one virtual device context, so you configure this just in global config. Like on the 5K, we would say the port channel load balancing method, we could say, do we want to use it based on just the source MAC address? Is it based on the source and destination MAC address? Is it based on the layer 3 information? Ultimately, this controls the hashing of how does one individual flow land on a member link. So if you think of it this way, if you have an individual conversation, let's say that you have a web server and you have a client. Okay, and the web client tells the server, I want to do an HTTP get. And you want to get a page, you want to get an image, whatever the resource is trying to get. Okay, if we have multiple physical links between the network devices in the middle, so we have links A and B. When this individual flow comes back, the flow can land on A or B, but not both at the same time. So the best analogy I've heard for this is that when you're doing port channels, you can think of it like a highway. So increasing the bandwidth of the link, like when you go from a 10 gig link to a 40 gig link, what you're doing is increasing the speed limit. But when you do channeling, you're adding additional lanes to the highway. So since you can only be in one lane at a time, your effective bandwidth is always going to be based on the member links. So in our particular case here, an individual flow is going to be limited to 10 gig. But the aggregate of all flows, assuming that we're statistically balancing them between the links, should be the aggregate bandwidth, which in this case is 20 gig. So in an ideal situation, when you go to upgrade bandwidth, you would change out the layer 1 link. So instead of going 10 1 gig links channeled together, you're better off going with one 10 gig link. You would get better throughput. Or likewise, if you have the choice of taking 4 10 gig links and channeling them together, you would get better throughput going to a single 40 gig link. Because the individual flows are still going to be limited based on the physical layer 1 connection between the devices. Now, the reason that you can control this, though, in terms of the load balancing method, is the individual traffic patterns might disagree between the different ends of the channel. So, for example, let's say in our particular case that this server here is where we have our, like let's say that this is our database server. Okay, so this is where we're running SQL and we have all sorts of other devices. Maybe we have like our web servers on the front end and they're calling the back end of the database. If we have tons of servers, let's say we have web 1, 2, 3, and 4, and they're all making calls to this database, when the traffic returns from the server and goes out, if this switch here is doing the load balancing based on the source MAC address, what would happen when it goes to make its decision about how am I going to load balance the traffic between the links? Well, from this switch's point of view, it's going to say, well, the source MAC address is always A. So if the majority of the traffic is coming from that direction, all of this traffic is always going to land on only one member of the channel. And what this is sometimes referred to as polarization on the links. That the switch keeps making the same decision over and over and over when it goes to do the layer 1 load balancing decision. Now in the case of Nexus, there's an easy way to check this from the CLI though. So you would set up your channel, you allow traffic to forward over it, and then from the CLI's point of view, you look at the show port channel traffic. What this shows you is what is the inbound and the outbound distribution of traffic over the member ports. Now the one that we're most concerned with is going to be what is the transmit value. So when I'm transmitting unicast, when I'm transmitting multicast or transmitting broadcast, we can see that these are almost on a 1-to-1 basis. The same with multicast. Unicast is on about a 2-to-1 basis. But we can see it's a fairly okay distribution between the links. Now, if one of them said 99% and the other said 1%, that would be an indication that we would need to change the load balancing method. But the thing to remember here is that the method is only locally significant. I could be doing my balancing based on source destination IP, and you could be doing it based on source destination MAC address. Because when I receive the packets in, I don't need to make any load balancing decision on that. It was up to you to figure out how are you forwarding the traffic outbound, as opposed to me to decide how am I receiving the traffic inbound. So depending on where the difference in the distribution is, if I were to see received unicast at 95% and 5%, what this means is that I would need to go to the upstream switch, which in this case was the 7K, and change its load balancing method, which is going to affect its transmit traffic, which means my receive traffic. So again, when you change the load balancing method, it only affects your outbound flows, which are the transmit ones. And somebody asked the question, what is the default one? It depends on the platform. In the case of the 5Ks, if we look at the show port channel load balance, it says for IP traffic, we're going to look at the source destination port, the source destination IP, and the source destination MAC address. So basically, it's going to be the L2 source and destination, the L3 source and destination, and the port number. So this would be like your TCP source port and your TCP destination port. And assuming you get some variation between all of these values, that hash affects how you actually go out the physical links that are in the channel. And again, in the case of the Nexus 7K, if we say globally the port channel load balance, notice that that command's not there. Where this would need to be configured would be under the admin VDC. So here we're in the admin VDC, and if we say port channel load balance, we could say what's the specific method. Okay, here if we look at the show port channel load balance, it says globally for the system, IP is based on the source destination IP address, and then we can also do this on a per module basis. So the 7K gives you more control of this. If we say port channel load balance, we'll say source destination IP layer 4 port and VLAN, and we can do that on a per module basis. So the idea of this is that if I have a channel that's both plugged into line card 1, I could change just line card 1's decision as opposed to changing it for 2 through 8 or whatever all of the other cards are. Okay, also you can set this globally for the system, and then it's going to be inherited by the other cards. But as I mentioned, this is only a locally significant outbound value, and you can check it by looking at the show port channel traffic. Okay, in this case here, this means that the load balancing method for unicast traffic is not that great. So if we check this again, show port channel traffic, we should see, and it's not going to be 100% real-time value, but what this is telling us is basically there's only one source and destination, which the source and destination are these two servers that we're pinging between. So since it's only one flow, this one flow always lands on the same member port. So there's nothing we could do to fix this other than upgrading the physical bandwidth. So server 7 and server 8, when they're sending the east-west traffic, they're always going to be limited to 10 gig here unless we upgrade to 40 gig or 100 gig down to the access layer for them. Okay, there's a question, if we need to configure the member ports in the channel, but we want to add a new member port, how can we have it inherit the config of the current members? Okay, so let's say we're going to do a channel now between 7K7 and 5K8. But we're going to do this incrementally. So let's assume that we only have one link to begin with, and then at a later time we want to come back and add a second link. So what we're going to do is create the channel just with one member and then see what is the end result when we want to add a secondary one. Okay, also to make sure that this is not affecting the rest of the topology from a spanning tree path selection point of view, what I'm going to do is disable these ports and these ports. So the only direction that 5K8 is going to be able to forward is going to be out that one channel. So let's say interface E13 to 5 and E16 to 7 are shut down. Okay, next let's look at the show run interface E1 8 through 9. We see the config is identical. Okay, next we're going to go to the other side, so let's go to 7K7 and we're going to show run interface E2 29 to 30. Okay, config is identical. So let's say we start with the first port. We're going to say on interface E229, we're going to put these into channel group 200, and we'll say the mode is active. So we're running LACP again. Okay, next on the other side on 5K8, we're going to do the same thing. But actually, before I do this, I'm going to turn logging on. Let's say terminal monitor. So we can see the syslog messages as the channel actually comes up. Okay, next let's go to global config. We're going to turn LACP on. We say feature LACP. And then at the port level, we're going to say they're in a channel and the mode is active. Okay, it says the port channel was created. Membership assignment is in progress. So right now, E18 was added to the port channel. It says first operational member changed from none to E18. So now the channel is up. Okay, we can also see it says the interface is up. This means from a layer 2 point of view. If we now look at the show port channel summary, now the port channel is working. Okay, even though there's only one physical member of the link, we've now staged the configuration that if we want to add another member later, we want it to be a non-disruptive change. So in other words, as we're forwarding these packets, like let's say as we're doing these pings, we want to make sure that we're not losing any packets as we send traffic actually between the servers. Okay, so let me see if I can set the timeout to this to be a little bit lower. I don't know if I can set this to be, let's say timeout in milliseconds to wait. Let's see if we can set this to, let's say 50 milliseconds.